what's been useful in your new role, and how is it being on the material side of the equation now?
And he says a lot nicer things about you now, just so you know, Greg.
Yeah, yeah, I like you better now. Your polo says KOKI.
Welcome to the Decode Podcast with Elias Malfovan, Daniel Stanfill, and Sean Kincaid.
All right, here we are back again, the Decode Podcast. We've got a couple of familiar faces on tonight, Mr. Shantanu Joshi with KOKI and Greg Starrett with KOKI. So welcome aboard, gentlemen. It's great to have you here tonight.
Thank you. Great to be here.
I'll just quickly introduce your bios. So Shantanu is from the great state of Ohio, and he's the head of customer solutions and operational excellence at KOKI. He has a master's in science and is a PhD candidate. He's also the VP of technical programs in the Ohio chapter of the SMTA and a frequent speaker. I know that we recently saw him at the STAR event. And Mr. Greg Starrett, yeah, he did. Mr. Greg Starrett is from Jersey. You'll hear that in his voice soon. He's the national sales manager from KOKI America. And Greg has the distinction of having survived 30 years in the SMT space, specifically in the area of stencil design, manufacturing, and sales. So welcome, Greg. And I also wanted to point out that Greg is missing the Eagles game to be here tonight. So
and the Phillies.
Tremendous sacrifice.
Wow. That's a double whammy.
So welcome. Thanks for coming on with us tonight.
Thank you, guys.
Yeah, thanks for having us.
Yeah, absolutely. This is, by the time this airs, we'll probably have already spent some time together in Chicago at SMTAI. But glad to have you here tonight. And I know we've been spending quite a bit of time with the two of you at industry events. KOKI seems to have like a real groundswell type effect right now. I know there's a lot of great things that are being done, and we've been able to see some of these presentations. I know Sean's talked about the fluxless solder and that whole formic acid reflow process, and he's still having a hard time computing that, so maybe you can help him with that tonight.
Sure.
But to start, I got kind of a lead-in question for you. You guys talk about being part of the customer's engineering team. So maybe we can talk about what's the story behind that slogan. Unpack that a little bit for us.
Sure.
All right. So, I mean, when we say we are part of customers engineering team, we are basically telling that we are collaborators in problem solving. So think about us as like an extension of customers process engineering group. So for example, let's say you have some issue on your production line. Let's say you get a field return and you don't know what to do about that, or you don't know the root cause. So you can obviously send that part to us, let us analyze it. We may ask you for some bare boards, maybe stencil design, some reflow profiles, and we want you to we want to work with you and find out the root cause, like why the problem happened, what's the root cause behind it, and what are some countermeasures that you can do. And then we'll share that report with you. And then we can also jump on a call with your end customer if you are a CM, and then can explain the report in detail.
Yeah, and I understand you have some pretty robust lab technologies, right? Or lab capabilities, FTIR, ion chromatography, SIR. So you can really sniff up and down the entire process, and maybe it's related to paste, maybe it's related to reflow, maybe it's related to stencil design, but you can get to the bottom of it in any fashion.
Yep, absolutely. And I think what we are seeing, it's not like a trend, but we are seeing like it's very easy to blame either the paste or the stencil or the reflow profile. And people kind of miss the part that, hey, maybe it's actually a bare board or a component which has a missing plating. So we see often that, hey, 99% of the components solder just fine. and then it's one of the components which have like an ununiform or non-uniform plating, and it's very easy to see that in EDX or FTIR, and then we point that out, and we have solved issues. Like sometimes you are in the bind that you cannot change the component, but you basically can add more flux or use more aggressive paste and then can get rid of that issue. So that's where we basically shine, because we would know exactly what the problem is and give potential solutions.
I'll go a step further with what Shantanu is saying is I've never bought an KOKI solder paste. Let me just put that out there first before I say this. And
Strong endorsement.
They have
Good job. Good job,
listen,
Greg.
if you go by the, like, if I tell you the full story of why I choose the person that I choose, I think you'll understand. But it has nothing to do with paste performance. But here's the thing that I can say about these guys:
Kickbacks.
Greg and Jerome, my local sales rep, have literally came to my shop and reflowed with the Kick Profiler multiple different paste types, and have tried to, and troubleshoot jobs for me. And it's not, I'm not even running their paste. So when they say like they're like an extension of your, it's almost like an extension of my team. They just want to help solve solutions. And then if they're there, you know, and the opportunity happens, and you know, we got a job coming up where I think KOKI is a good fit. So then we'll put them in. But yeah, I appreciate that type of help, you know, and they don't pressure me on sales or nothing like that. They want to help solve my problem. It's very
So,
unique.
Shantanu, how many more prototypes are you going to let Sean send for SIR testing before
No, I
you
don't
start
send them.
making him
He
pay?
comes, like Jerome comes to my shop when he's in the area servicing the other customers, and then if I have a problem with the job that day, Greg was there that one day. We did that glass circuit board.
Yep.
And we profiled it together. It was it's just nice, you know.
Yeah, this is something we do all the time, guys. We know we have a good product, and we want to get our name out there, and we want to get this product into our customers' hands, right? So,
Yep.
you know, I spent 4.5 hours today at a customer's shop. Their profiling was so out of whack, and we took the time to help them, walk them through that. You know, they had 30%, you know, reject rate. You know, they're having rejects in the field, and we're problem solvers. We can help them with that. So, you know, that's our bread and butter. You know, that's really what we want to do. We want to provide that service and a great product for our customers.
Right. And then it's also a little bit selfish. So we want to say that because at the end of every year, we basically publish like lessons learned, like a small white paper. So, for example, last year we did something on de-wetting. So, based on all the requests that we get from all over the world, we basically categorize those into, hey, these are the top 10 defects, or basically these are the top 10 causes for de-wetting. And then we go one by one. So we go like, for example, poor plating. Okay, so how do you figure out that it's a poor plating? What are the obvious reasons? And then what are the countermeasures? So we're going to have a small webinar on this end of this year. But then basically, when I say it's a selfish thing, it's we want to share our knowledge. Like that's the whole idea, so that people can understand that they can solve their issues without actually have to wait for 2-3 weeks. And if the knowledge is out there, they can obviously refer to the white papers or our studies, and then obviously go from there. So
Elias, that's a good lead into your question.
It is. It's a very good lead into my question. So I was curious about what you encounter as the most common, let's say, paste-related challenge. Like, which defect are you seeing most commonly, and how do you address it?
So difficult question to answer, because it all depends on which region or which industry you're talking to. For example, when we talk about mill aero, typically they are dealing with a lot of legacy components, legacy parts, legacy boards, and they don't have a choice to change that. So there we pretty much deal with either graping issue or non-wet opens, or talk about like de-wetting, for example. So they don't have a lot of control as to what they're going to get, because someone might have bought the components 20-15 years ago and the products are still running in the industry. So, and then obviously when it comes to mill aero, they want to clean everything. So we basically can give them uh, the most aggressive pace that we might have, but that might not be good enough for them. So we basically have to add maybe a little bit more flux with that, or change of formulation a little bit. But that also is not possible, because with mill aero, once the material is specced in, it's pretty much it is like there is no way you can change it.
It
So
might
then
literally take an act of Congress to change it, right?
pretty much, yeah.
Yeah.
So they can basically play with some aperture designs, maybe add more pace, or maybe add that exact same flux, just the paste flux as a top up, so that there is enough activation out there to remove those oxides. So when we talk about like automotive or consumer electronics industry, which is dealing with the like more functional products. So for example, think about ADAS products, automated driver assisted systems, or anything which has like, now the car has more powerful computer than your PC. So for example, you have a lot of functions, a lot of IOs, meaning you're going to have micro BGAs, anything like that. We typically start talking about head and pillows, non-wet opens, and then people start to talk about, because that industry, obviously the cost per board is very low, so they don't want to spend any more money on cleaning the boards in the saponifiers, whatnot. So then you are talking about a paste which has like an anti head and pillow property, or you have a paste which has a flux activation slightly higher than the standard average in the industry. So it all depends on which industry you are talking to, but these are pretty much what we talk about like day-to-day basis.
So how many formulations of paste do you have at KOKI?
Close to 255, I think, give or take.
Okay. And I've heard you say that you'll do a custom formulation for any custom, like when the application demands it. So uh, how is there possibly an application that isn't solved already by one of those 250 pastes?
Hey, applications are changing every day. I'll give you a small example. So just think about yourself like doing something where uh, you need an impedance or a capacitance of certain microfarad. There is no argument about that. And now you are dealing with some devices which are super new to the market, and then they will start reacting with the ingredients in the flux. So, for example, some of our customers who do some acoustic products, they were having issues about uh, some of the ingredients in the current flux, or the existing flux that they were using. So they basically had asked us like, hey, can you develop a paste where you can take literally, let's say if there are 11 ingredients in the paste, can you make 11 formulations by taking out one ingredient at a time, and then send us the product, let us test it, and then we'll tell you if this ingredient is the cause or not. So there are lot of challenging applications these days, as like IOs are increasing, the footprints are getting low, the real estate on the board is getting low. You just never know what application you are going to get. So sometimes we deal with customers who need type 5, but their type 5 doesn't mean that it's an industry standard type 5. So they might need solder about, like for example, when we talk about type 5, we talk about like, hey, 80% of the solder sphere should be between 10 and 25 micron. Now, their specifications may be a little bit more tight, because they know that if the specifications are haywired, then they're gonna get a clogged aperture. So they will say like, hey, that's fine for industry, but for us, we need 80% of the part, instead of 80%, we need 90% of the particles between 10 and 25 microns. So now that's not really an industry type 5, but it doesn't matter because it's their type file. So we can cater to their application. That's why we have so many different formulations. So we will go with a standard off the shelf formulation, and then we'll get the feedback from the customer and then basically develop a formulation which is almost a tailor-made formulation to that particular customer. So
Yeah, we have a major automotive manufacturer that we're working with now, guys. And Shantanu, how many iterations of that have we made for them? And there's, we're checking
yeah, at least six,
process.
seven.
They
Yep.
want everything checked, right? They want the wetting, they want low voiding. They don't want any head and pill. Like we're trying to make it so there's no failures in the field. And sometimes you have to go through some serious testing to get this nailed down. So
I mean, I wouldn't say like these are standard numbers
right.
because these are our numbers. These are KOKI type 4. So sometimes our type 4 can be someone else's type 4.5. So it really all matters is like
That's what I was
what
going to ask
is.
you. Do you have 4.5? Because that's all the rage.
No, we don't have a 4.5. We just keep it simple. 3, 4, 5, 6. So
Greg, I want to clutch you in here
There's variations in powder size though between that,
for sure.
4 and 5. There may be some 4.5 in there, right? So it's just we
4.75.
like to keep a range.
Greg, I want to clutch you in here because you and I spend a lot of time in the same sector of the industry. So how has it been for you transitioning from the stencil end of the printing process to the paste end? What's been useful in your new role, and how is it being on the material side of the equation now?
It's funny
And he
because
says a lot nicer things about you now, just so you know, Greg.
Yeah, I like you better now. You're pulling us as
I'm
KOKI.
still getting data from customers, right? I think that's an added bonus for KOKI. We can take the data, we have the software to look at it, we can make recommendations. I can work with the stencil guys on the final the final product. So, yeah, I mean, I think KOKI didn't have somebody like me from the stencil side. I mean, Shantanu's very knowledgeable about this stuff, but now we have that, even another layer of engineering support where we can help our customers in that way. So I think it's been good.
yeah, he's been awesome.
You spent a good portion of your career, at least in the earlier days, in actually doing CAD and stencil design, right?
Yeah, back in, when I started with metal etching technology, I mean, I started their CAD program. Back then, everybody was sending in, plots, films, and
Yeah.
we were building the stencils and using micro modifiers to, reduce the aperture size. Really wasn't a CAD program to do that. And then things kind of evolved, and we set up a bulletin board system where our customers could send files to us, got a photo plotter. So, I watched it from the very beginning, man. We were, you and I talked about it. We were making brass stencils back then. So chemically etched, and, as these components got smaller and smaller, now it's like you can't do anything but laser cut them or electroform them. The chemical etching it's good for doing steps. That's about it these days. You would probably agree with that.
Yeah, and even then, I think there's better mousetraps for steps now. So it's had its day.
Yeah, for sure.
Shantanu, when I was out at the Star event, one of the few times I've been allowed outside of my cage this year by my lovely wife, it was. She's never gonna hear it anyway, so it is what it is. It'd be priceless if she did say it back one day. But one of the things I remember watching the formic acid presentation that you gave out.
I knew this.
And I think I looked at Daniel during it, and I was like, "Have you ever heard of this before?" And thankfully he said no.
Totally, of course.
And, yeah,
No.
and it was like voidless paste, and I'm like, just the whole thing blew my mind. And I remember saying to him, like, this could just be like an April Fool's Day joke right now. We would have no idea if it's real. Like, I don't even know if what he's talking about is real. Do you ever, I mean, what it solves is pretty amazing. Do you ever see it becoming more mainstream than it is currently?
Yeah, I think I do see good potential with that, because if you think about the applications is more on the power management side, so power electronics, and as we all know, I think managing power is gonna be essential for like heavy duty applications. So just think about uh, aerospace, military. Think about automotive. Everything is getting more powerful these days. So managing the power what you are going to generate and making sure it's optimized and not wasting any power is a great news. So in order to do that, you will need a lot of IGBTs and MOSFETs. So when we talk about IGBTs or MOSFETs, obviously we talk about preforms, because currently they are either made with a paste which is cleanable, or they are made with preforms. So now here is the catch. So the problem right now is the designers don't have a freedom to choose what die size they can use, because the preforms are super expensive. So for example, if you do a standard size 10 by 10, 15 by 15, anything which is very standard, you don't have any problem. But now when you go and start talking about odd shape preforms or a different shape preforms which are not standard, then the initial cost of investment is very high. So this is basically the premise for developing a paste which is designed for formic acid. So are the formic acid ovens pretty standard? I would say not really, but
You have to have
people
a
who
custom reflow oven too, right? I think
Yeah.
from
right,
your
right.
present.
So currently, whoever is using preforms, there is a, I would say 30 to 40% chance that they are using it in like the preforms in formic acid reflow. So because they don't want to add flux. So formic acid is, think about formic acid as a reducing agent. So what flux does, it reduces the oxides and makes the salt, makes the surface soluble. Same exact thing what formic acid does. So you can actually reflow a preform by itself if you reflow that in a formic acid environment. So
How
now, yeah, go
how
ahead.
does that affect cleaning at all? I'm just
There
curious.
is no cleaning required because you are not adding any chemicals. Formic acid is going to reduce it, reduce the oxides, and then you're going to have the surface soluble. The preform is going to melt, and you have your solder joint. No problem.
So truly no clean
With
then.
no
Truly,
residue, zero
no.
residue.
Yeah, that's so we never say zero void paste. We say zero residue, like zero flux residue paste. So now where our product comes in is like if you basically can design a stencil however you like. You do not have to worry about having the same size preform, because you can pretty much, it's gonna be like a standard solder paste, except it's not standard. So you can print it as if it's a standard paste, and once you start reflowing it, formic acid reflow, everything is going to evaporate, and you're going to get a solder joint as if you soldered like a preform. So
That's so cool.
that's the beauty of the product. So,
And there's only a few ovens out there, guys, that are capable of this, and they're very expensive. And I think
and I mean,
Probably.
I'll give you full honesty. So now the natural question is going to come like, okay, you have a medium, let's call it flux, for example.
Oh, I
Where
thought
is
you were
it
going to
going?
say the natural question is, so you obviously have a demo center in Nebraska for this product because it's like the center of the country, and you'd want to show everybody how it works.
Yes.
Sorry, yeah, go ahead.
Yep. No, no, no. Good question. But what I was going going towards is the natural question is, hey, where is the flux going? Or where is the medium going? So typically we say that the ovens with formic acid are already inbuilt with, we call it FMS, flux management system. So there are traps which are designed inside the ovens, which basically uh, like capture the medium, which is flux, and you don't have to spend time on preventative maintenance. So
Is it
those are already
filters
inbuilt
or a
features.
vacuum, or how does
Yeah,
the
there are multiple ways that you can use. I don't know if you have seen a system where they pass the gases through water and collect the flux residue, or there can be filters, there can be, I'm not an oven expert, so, but I've seen multiple different methods by which they collect the flux inside. So.
Daniel's never had to do maintenance on an oven, so he doesn't know how that's done. But yeah, you're
I was
correct.
maintenance guy here for 2 years. I mean,
Allegedly,
so that means I did
allegedly.
maintenance on the ovens at least like once or twice, right?
Yeah. The BTU warning pops up way too quick. Every time it's like change the flux filters. I'm like, we're gonna click completed. We're gonna click completed on this.
So allow me to play devil's advocate here. If we say that it's what was the term you used? A residue
Zero flux
free,
residue.
zero flux residue. Okay. So, and I think maybe Daniel or Sean threw the term a true no clean process. Does the formic acid reflow process do anything to eliminate the other suspects in board contamination? Does it neutralize any other organics that may be on the surface of the substrate from
Your
handling?
Cheeto fingers.
Yes, yeah. To use a Mike Conrad term, the Cheeto fingers.
I don't think so. No, you have to be. I mean, when we are talking about this process, I mean, obviously you are spending a lot of money in getting a formic acid reflow oven. It's not cheap by any means. So mostly this is used in a wafer fab, pretty much. So most often than not, it's gonna be a automated process. So I don't think there is gonna be like a human interaction as such. It's gonna be, it's an inline oven, so it's not a batch style oven. I mean, there are batch style ovens possible and there are available out there, but obviously you are making millions of the IGBTs and MOSFETs or discretes to get your money's worth. So typically we don't have the issue of like, for example, handling immersion silver boards by bare hands. So we don't have that issue, thankfully. So.
It'd be a cool design of experiment, though. Somebody just eating some Cheetos.
You probably see boards getting treated for surface preparation and cleanliness before the assembly actually starts. I imagine if you're doing something like
that. Right. Yeah. I mean, the process is totally in the nitrogen environment, and then you are gonna purge the formic acid under pressure in certain zone, and then allow the vacuum to do its magic. So.
Is there something besides just going to like a smaller type, like type 6, that you guys deal with customers on to help with smaller geometries and ultra dense and complex designs?
Right. So now we are switching topics. So when we talk about formic acid reflows, we are typically talking about type 3 or type 4 because obviously the die size are big enough. So when we talk about type 6, I think there are some cool applications out there which we design specific products for. So think about like, we call it a micro LEDs, but they are actually nano LEDs. You can inhale them. They are that small. So you have to be super careful.
Don't
So
tell Sean.
imagine the pad size. I mean, the pad size is so small that the amount of paste deposited is going to be equally small. So the challenge comes in where how the part is going to adhere to the amount of small solder paste on those pads. So we have to develop a chemistry where the solder paste stackiness actually increases as the time goes on, not reduces. Typically, the tackiness reduces as the time goes on.
Yeah.
So we had to develop a special formulation so that the parts O2 metric, for example, will adhere to the small amount of solder paste you have on the pad. So that was an interesting project.
So if it gets tackier over time, what happens to your paste life on the stencil, like during the process? Like,
good question. So the tag time, even though it might increase, the paste is going to start to basically gel up quickly, meaning it's going to start to, I wouldn't say harden up, but it's not going to roll as good as it would if it's a fresh paste. So typically for that particular product, we basically sell 250-gram jar, so half the quantity of jar that a normal jar would have, so that you are not going to take the paste out in big numbers or large quantity and then spread it on the stencil. So you're only going to take out paste for, let's say, I don't know, 100 boards. You can replace the jars, that's fine, but once you open it up, you hopefully will use it in one day or so. So
I'm so sick of this miniaturization thing. It's disgusting.
It's
I'm
probably
like,
going away soon.
I can't stand it. It's just it's unnecessary. What do we need a nano LED? What are we trying to show mosquitoes the way to go somewhere? You know what I'm saying? Like if it's that small, what do we need
There
it
are
for?
robots.
So you
that-
don't want to hear about us working on type 7 and type 8 paste then?
No, that's fine. I'm okay with that stuff. There's a need for that. You know, like there's a need for that. But we don't need to.
No, I think you have a valid question, Sean. I think the problem why people start to use small parts is because they're getting cheaper. So the standard parts will get cheaper once they get smaller, because some big customer is using that, and that will get the price down. So that's the reason that, hey, if I'm going to get a small LED at quarter of the price, then if you have the process ready, you would rather use that than a standard LED by paying 4 times more cost. So that's where it's going. It's not because all the applications need it, but it's the necessity of the present that you basically gonna buy the components which are first readily available and second cheaper. So
I want to rewind just a quick second here. You've talked quite a bit tonight about kind of some of these custom applications, and I'm imagining, Shantanu in the lab in his mad scientist coat coming up with all these trick solutions, right? And they work perfectly in that really controlled environment. How do you take that, kind of lab formulation and send it into Michigan or Nebraska and put it into the, the realities of a production SMT line? What are some considerations and challenges that you have to have at the forefront of your mind to take, a beautiful thing that you developed in your lab and make it work in the real world, per se?
yeah, actually, it's amazing question. So, we deal with customers from all over the world, different parts of the world, which may or may not have exact temperature, exact humidity. Sometimes the temperature goes up or down, humidity goes up or down. Someone forgot to shut the door on, and then it's super humid environment. So we have a lot of chambers inside our lab, where we actually start from ground zero, where we start doing what we call as a transportation simulation. So we call it A square test, Alaska to Arizona, if it's easier to understand. So, like, take extreme cold temperature, extreme hot temperature, and then you basically do like a simulation where you are gonna do a simulation for a standard transportation where, hey, okay, it's gonna leave the factory at this time, it's gonna spend some time at the dock, it's gonna fly to, let's say, Asia, is gonna spend some time there, and we do that as a part of our product approval process before it's even released to the customers. So we will have different regimes that are built into a transportation chamber, where it will go like, hey, it's going to stay in Malaysia middle of the summer for 40 degrees C for, let's say, 12 hours in a hot truck, and someone forgot to deliver it on a weekend, so it's going to stay outside for 3 days, and then what's going to happen to the paste? Sometimes what we do is we basically take a data logger, put it uh, in a jar of paste, not in the jar of actual paste, but in the box, and then it will record the temperature, and then we will actually not deliver that box to the customer. That box will again travel back to the factory. We'll take the temperature out, the data logger out. We'll see how the temperature is, and when we do the testing on that particular paste, and we do that every year for some of the customers in extreme temperatures, so we know that the product which we are building is going to last in extreme conditions. Because sure, we will have a data sheet which will talk about, like, hey, we need the temperature between 23 to 27, RH between 40 to 60, like everyone does. but you know it's not going to happen all the time. You have to prepare for the worst. And I'm not saying we are the only ones. I'm sure there are a lot of other companies, because obviously there is a lot of business out there, and we see products which do pretty good in that condition. So that's just one of the conditions that we do. The other things that we also do is, let's say the product is developed, now you are using it, and you suddenly start saying that, hey, the product is not rolling, or the product has something where it starts to like splatter a lot. So we basically analyze, like, hey, how's the stencil coating? Are you using a correct stencil? Do you feel like there is something wrong with this part? Lot of solder paste, did you see that before? It may not be our
It's
product, or
usually the
maybe our
stencil,
product.
honestly. That's what I found. It's almost always the stencil.
So
Actually, while we have you guys here, I've always asked these solder paste people, like, you gave some pretty tight ranges just now with some numbers you were giving, but when we talk to solder paste people, we always like to ask about the recommended speed of print, and why the range that I tend to see is somewhere in the range between like
10
5
millimeters per
millimeters per
second to
second and like
100,000.
25,000 or so. Yeah. So yeah.
no, so typically our standard speed is anywhere between 30 to 60 millimeter per second. But there are some of our customers who requested us to develop a paste to print at 250 millimeter per second for a
And still have
specific
good
application.
fill and everything.
Everything has to be exactly the same. So we have a formulation for those particular application, but typically wouldn't say, like, for the most part, that printer is not the bottleneck. So it can be for some applications, but more often than not, it's pretty simple process. So I would say 35 to 40 millimeter per second standard speed, you should be in okay shape. So
And Greg, I know before we got on, you said there you wanted to complain about Shantanu while we had the platform. So was there? No, I'm just messing. We're really grateful, both of you, for your time and want to respect it. So if there's anything you guys want to talk about before we let you go, Greg, would tell the people where they can find you and anything else you'd like to cover.
Yeah, I mean, Greg at KOKIAmerica.com. Reach out. Be happy to answer any questions. Shantanu at KOKIAmerica.com.
that's a hard spelling.
Sales.
Send at Greg at KOKI America.
That's really why you guys brought him along, right? Like, so many people are having such a hard time spelling Shantanu.
Yeah, when
like,
we travel
gotta get-
together at Starbucks, say, what's your name? Greg. Oh, you don't look like Greg. I was like, yeah, I'm Greg. Believe me. So.
Okay. No, that's great. Well, thank you both for your time, and
Yeah, thanks, guys.
thank you
Thanks,
to the
guys.
audience for watching.
Look forward
and
to
staying
seeing
along.
you in a couple of weeks. So
Yeah, it'll be fun.
Absolutely.
People will we will have already got to hang out by the time this airs, so it was great seeing you.
Yeah, you too.
All right. Until next time. Thanks, guys.
All right.
thank you.